Let's take a look at page 2, which is nothing but factoring. On question 5, that looks pretty complicated, but just like anything, we break it down into parts. First thing we do is look for what goes in all of them. And notice 12 goes into 24, but it doesn't go into 16, but 4 goes in all of them, doesn't it? So we're going to factor out a 4. Then notice all three terms have an x. I always pick the smallest one, so I'll go x squared. All three terms have a y, and my smallest one is y squared. All three terms have a z, and my smallest one is z I can see, so I'm going to factor out a z. Now, let's write down what's left over when you factor that out. 4 times 3 is 12, or 12 divided by 4 is 3. I'm missing an x, so I'll put the x in there. I've got the y squared and the z, so that's all I do. Minus, and then 24 divided by 4 is 6. I've got the x squared, but I'm missing the y. And I've got the z. And then my last term, 16 divided by 4 is 4. I've got the x squared. I'm missing a y. And I'm missing z squared to get to z cubed. Because z times z squared is z cubed. And that's all you would have to do. I should say all you have to do. That's all you have to do. Now, can I factor what's left over? No, because this isn't a squared. I don't have anything. There's nothing the same there, so I can't factor that. Now, let's take a look at question 6. Now, in question 6, the first thing I notice, there's 4 terms. So I think I'm going to factor this by grouping. But I always check, can something go into all 4 of them? In this case, no, because 4 doesn't go into 9, and I don't have any variables on the 45. So we're just going to factor 2 at a time. 4x squared, y squared minus 9y squared. I'm going to factor out a y squared. So we're going to say y squared, and then I'll have 4x squared minus 9. When I look at my next two terms, 45 and 20, 5 goes into both of those, don't I? So I get negative 9 plus 4x squared. Notice my binomials on this one. They have the same terms, they're just backwards. So I'm going to write that as factoring out 4x squared minus 9, and then y squared plus 5. But 4x squared minus 9 is a difference of squares. The square root of 4x squared is 2x. The square root of 9 is 3, so I'll say 2x plus 3, 2x minus 3. Now, the second parentheses, you have a y squared, but it's not minus, and 5 is not a perfect square. So that's all we can do. There's your answer. 2x plus 3, 2x minus 3 times y squared plus 5. Let's take a look at number 7. Okay, first thing, I don't like that negative in front. That makes it confusing. So I'm going to factor a negative 1 out right away, which means I change my sign. So it becomes x squared minus 5x minus 24. Now I want two numbers that multiply to negative 24, and they, in this case, subtract to negative 5. Well, that would be negative 8 and positive 3 1/10. So I'm going to say negative 1, that doesn't go away, x minus 8, x plus 3. There's our answer. Okay, number 8. Let's take a look at that one. First thing I notice, on that one is I've got 3 terms again, but 10 is not a perfect square. So I always want to check if I got a leading coefficient, that's a perfect square. It isn't. I can't take a number times itself that give me that. So then we'll try to factor it through the British method. 10 times negative 21 is negative 210. And then 29, so I want 2 numbers that subtract to 29, because one's positive, one's negative. Obviously, since it's positive 29, the bigger one is going to work. Now, I don't have a clue on that one. So let's start doing some guessing and checking. So 1 and 210, well, that subtracts to 209. We can see that's not going to work. 2 and 105, that subtracts to 103. 3 goes into 210 70 times. So 70 minus 3, that's 67. I'm getting closer, but I'm not there. Well, 4 does not go into 210, but 5 does. If I take 210 and I divide that by 5, I get 42. Well, that gives me 37. That's not it. 6 goes into 210. So if I take 210 and I divide it by 6, oh, there we go. If I put in negative 6 and positive 35, that's going to work, isn't it? So I'm going to rewrite my term as 10x squared minus 6x plus 35x minus 21. So I factor out a 2 out of the first two, so I get, factor out 2x, we'll say, and I'll get 5x minus 3. I'll factor a 7 out of 35 and 21, I'll get 5x minus 3. My 5x minus 3s are the same, so I'll factor out 5x minus 3 and 2x plus 7. You could have gotten that by guessing and checking, but I like the British method. Okay, let's take a look at number 9. Now, number 9 looks like the same thing again. I'm going to, 3 is not a perfect square, so I can't do that. So let's try multiplying the first and the last. That's 36. So I want 2 numbers that multiply to 36. In this case, they add to negative 14. So in other words, they have to add. They're both going to be negative, but they have to add. And once again, I can't think of anything off the top of my head, so I'll go through process of elimination and be strategic. 1 and 36 adds to 37. 2 and 18 adds to 20. Oh, I'm getting close there right away. 3 and 12 adds to 15. Oh, I'm only 1 off. 4 and 9 adds to 13. Uh-oh. This is 15 and this is 13, so it's got to be in between there. It's going to be a decimal. So we're going to say this is going to be prime. So number 9 is prime on this problem. And don't be surprised if there's a prime polynomial on your test. Now let's take a look at number 10. Now, number 10, that's more like our first problem, isn't it? I look at all 3 of these, and I say, what goes into all 3 of them? Well, 3 does, doesn't it? And then there's an x in all of them. There's not a y in all of them, so I just factor out the x. So what's left over is x squared minus 8xy plus 12y squared. Oh, can I factor that parentheses? Can I find 2 numbers that multiply to 12 and add to negative 8? There'll be negative 6 and negative 2. So we'll get 3x, whoops, got the wrong pen color there. So I'm going to say 3x, it'll be x minus 6y. I include the y because of the y squared. And then x minus 2y. And there we have it. Let's take a look at number 11. Okay, number 11, once again. But do you see something right away? We've got x cubed here. This has to be an even power to factor it, because there's no way I can combine my terms and get x squared from x cubed. I'd have to have an x, and that doesn't give me x cubed. So I don't have to look for my numbers. This one is also prime. And I do believe, let me shrink this in. I wanted to make it big so we could show our work. That's it for that page.